Hello everyone. In this third video, we will learn how to use integration, how to use trigonometric identities for solving integration question, that is type 3. We'll cover exercise 7.3 here. So first step is you have to use suitable trigonometric identities which you have already learned in your class 11. So basically this is the formula of cos 2x from where we have derived the formula of sine square x. So sine square x is 1 minus cos 2x upon 2. Cos square x is 1 plus cos 2x by 2. Sine cube x is 3 sine x minus sine 3x upon 4. Cos cube x is cos 3x minus 3 cos x by 4, just opposite, okay? So sine 2a is 2 sine a cos a. 2 sine a cos b is sine of a plus sine of a minus b. 2 sine a sine b cos of a minus b minus cos of a plus b. 2 cos a cos b is cos of a plus b plus cos of a minus b. Sine of a plus minus b is equal to sine a cos b plus minus cos a sine b. Cos of a plus minus b is equal to cos a cos b minus plus sine a sine b. And then step 2 is you will use the direct formula. Now it might happen that in some questions you will not be able to use trigonometric identities. Then what will you do? Then you will use these given hints so that the integration becomes possible. Now, what is the hints? If a under root of a square minus x square is present in the question, you will put x as a sine theta or a cos theta. I'll show you how you can put this. You know, why will we put this? So suppose I put it as a sine theta, children. So a square minus x square can be written as a square sine square theta, and I can take a square common. So under root of 1 minus sine square is left. So you know the identity. 1 minus sine square theta is cos square theta, and under root of cos square theta is a cos theta. Similarly, if I'll put in place of sine, if I'll put cos, I will get sine here. And since it is under root of a square plus x square, why do we put tan and cot? Because we know that 1 plus tan square theta is sec square theta, and 1 plus cot square theta is cosec square theta. Similarly, when under root of x square minus a square is present, we put x as a sec theta or a cosec theta. Again, why? Because sec square theta minus 1 is tan square theta, and cosec square theta minus 1 is cot square theta. So that is how these three hints are derived. Now, very, very important, 4 and 5 are literally similar. If under root of a minus x upon a plus x is present, or reciprocal of it, we will put x as a cos 2 theta. Again, let me explain why a cos 2 theta. Because when we put, again, a can come common and it will get cancelled. So under root of a cos 2 theta, right? Children, this can also be written as 2 cos square theta, and under root of 1 minus cos 2 theta. Again, it can be written as under root of 2 sine square theta. That means these terms will get simplified. Similarly, if a square minus x square is present in the under root and divided by a square plus x square, we will put x square as a square cos 2 theta. Now let's move. How to solve these questions. Now that's the catch here. Now let's talk about the first question. Again, very, very simple. I already told you sine square theta. I already told you the formula. Sine square theta, the formula is 1 minus cos 2 theta. So in place of theta, we have 2x plus 5 upon 2. And you can separate out and integrate, children. Half dx, I'm not going to do the integration for you. That you can do it on your own. But you just have to remember this, children. Whenever you do, okay, let me solve the first question for you. So whenever you do integration of this cos 4x plus this, so it is sine 4x plus 5 upon derivative of 4x plus 5, that is 4 plus c. Do not forget the chain rule. All right. So Similarly, question number 2, you remember in question number 2 again we will use the formula directly. It is always better to write the bigger angle first. So cos A sin B, right? Or I can say it can be written as sin A cos B also. So if I multiply, first step is to find the formula. Again, we will use formula here. So half of 2 sin A cos B. The formula is sin A plus B, children, plus sin A minus B. Right? Again, you can integrate, separate it out and integration. And you know sine of minus theta lies in the fourth quadrant, children. And after school to college, in the fourth quadrant, sign is negative. So minus sign will come out, right? So this question will become half integration of sine 7x dx minus half integration of sin x dx, right? I already explained why sine of minus x is negative, okay, minus sin x. All right, so this is how you will go about question number 2. Suppose we have to solve question number 3 now. Again, question number 3, same formula, cos 6x. I told you just write down this way so that it becomes little easier and we don't have to use the quadrant formula to check the sign. So first of all, let's use the formula here. 2 cos A cos B. Formula cos of A plus, now I'm using it directly. Cos of A plus B, that is 6 plus 4 10x, plus cos of A minus B, that is 6, that is 2x, into cos 2x dx. Just open the bracket, half cos 10x into cos 2x dx plus half integration of cos square 2x dx. Now here again you multiply it by 2, divide by 2, and you can use the same formula which I've used here in the first step here. And how will you integrate this? Again, you remember cos square theta, the formula is 1 plus cos 2 theta upon 2. Right, children? So this is how you will integrate. Obviously, this can be integrated the same way. So it will be 1 by 4 twice of cos 10x cos 2x dx plus this. Right? You will use the same formula here the way I've used the formula in the first step. All right. So this was your question number 3. Similarly, question number 6 will also happen the same way. Question number 4. Now again, children, question number 4, very simple. It looks little difficult. See, there are two ways to solve this question. If you either you use the formula of sine cube x, right? The formula is 3 sine 2x 3 sin x minus sin 3x, right, children? That was the formula, upon 4. This is how, and just separate it out and integrate. Or suppose you forgot the formula, you don't remember the formula, can I write it as sine square 2x plus 1 into sine 2x plus 1? And this sine square can be written as 1 minus cos square x using the identity. Now you can put cos 2x plus 1 equals to t and you will get this as dt, right? So this is one more way to do. We can use the substitution method also. That is the last video which I referred. Substitution method. Now, similarly, if you talk about question number 5, children, question number 5 also, either it is a very, children who try and use the formula of sine cube x and cos cube x, they make a lot of mistake, because the question, when you will these terms are in multiplication, the question will run into pages. So that is why I will multiply and divide by 8, children. I'll tell you why I have taken 8, because cube, I need cube, right children? So twice of sine x cos x whole cube, only 8 can be written as 2 cube. That is why I have multiplied and divided by 8. So this will become sine cube 2x dx. Now this question and question number 4 is same. So now you can solve it the way you want to. Okay, question number 6 I've already told. 7 is again similar to question number 2. So I'm not going to tell you that. You can do it on your own. Question number 8, again direct formula. Integration of 1 minus cos x upon 1 plus cos x, again direct formula children. 1 minus cos x formula is, what is 2 sine square x by 2, right? And 1 plus cos x formula is 2 cos square x by 2. So again it becomes tan square x by 2 dx. Now this integration I have already taught you in the previous video. You can already do it, right? Now similarly, if you want to do question number 9 children, if you want to do question number 9, cos x upon 1 plus cos x. This is the question. Now can I just create the numerator if I get stuck in a particular question and separate out? Now again, this and this gets cancelled. Why I have to separate out like this? Because I know that 1 plus cos x and 1 plus cos x will get cancelled. That is why I separate out the pair together. Now here again, here is the integration of 1 dx minus, again, you know the formula. 1 plus cos x. The formula is 2 cos square x by 2 children, right? And you can obviously integrate 1 dx minus half integration of sec square x by 2. When you are integrating, again a reminder, please do not forget the chain rule, that is, whatever is the integration of sec square x by 2, you will also divide it by the derivative of x by 2, right? So that's the mistake which many children do. That was question number 9 for you. Now for question number 10, integration of sine 4x dx. Again, very simple. Can I write it like this? Sine square x can be converted as 1 minus cos 2x by 2 whole square, again using the formula, and you can open. 1 by 4 can be taken out. Alright children, similarly question number 11 can also be done. Question number 12 is very simple. Sine square x. Now can I write sine square x as 1 minus cos square x children? And now you can just use algebraic identity. A square minus b square is a minus b into a plus b. And cancel with the denominator and integrate. That is how you will go about question number 12. Now question number 13 is again a HOTS question children. I'll show you the mistake which happens in this question. Cos 2x minus cos 2 alpha upon cos x minus cos alpha. So if I try and use the formula cos 2a, formula is 2 cos square x minus 1 children. Similarly, here also it is 2 cos square alpha minus 1. Of course, dx will come. Now, just open the bracket and minus 1 and plus 1 gets cancelled. 2 can be taken out. So the question will be reduced to this. Now, just use the same identity. A square minus b square is a minus b, a plus b. Now, this and this completely gets cancelled. Now, here is the mistake which can happen. When we integrate by separating it out, sorry, it was plus here. Integration of cos x we know, right children, which is sin x. And cos alpha has to be taken common. Alpha is a constant children. So it will be only integration of dx, which is x plus c. So this is where the mistake can occur. 99% children will write the integration of cos alpha as sin alpha. So you have to remember that. Don't have to make that mistake. Okay. There is one more HOTS question here. I mean, two more. HOTS, this is also HOTS, and 22 is also HOTS. So rest, I will tell you these both questions. Rest, you can try rest of the questions on your own. And if you have any doubt, please leave me a comment. I will get back to you. Question number 21, sorry. It looks little tricky, tough, but it is just a one-liner answer. Children, you can't use substitution. Again, a mistake is many children try and say that put cos x as t. But if we put cos x as t, there is no term as sin x. So we cannot put cos x as t. We can't use the substitution method. But we can say, you know that using the quadrant formula, sin 90 minus theta is cos theta. Right, children? So this will be sine inverse of sine theta will be only theta. You know the simplification. You already learned in your inverse trigonometry chapter. And now you will separate out and get your integration. That's it. That is question number 21 for you. Now the last question, 22. Again, this is a very, very important question. And if you have not done this question earlier, this question you won't be able to solve it for the first time. So we will multiply and divide by sine a minus b. And we will create the angles which are there with the cos. That means somehow we have to create x minus a and x minus b. So how to create that? 1 upon sine a minus b integration of sine a minus b plus x minus x. Mathematics rule again, children. If you are adding something, you have to subtract the same thing. Now we will pair it, children. Now I need x minus b, so this becomes my one pair. So 1 upon sine a minus b remains as it is. So sine of x minus b, I have taken, this is my second pair. I have taken minus sign common since I need x positive and x minus a. Check. Did we get the angles which are there in the denominator? So that is the first funda. Now the question is not that difficult. Sine of a minus b. So we will use the formula which I have given. Sine a cos b minus cos a sin b upon the denominator. Of course, there is an integration sign, there is dx and there is 1 upon sine a minus b outside. So now the rule, you will just separate out. When you will separate out, children, you will see that this and this gets cancelled. This and this get cancelled. So we get tan x minus b dx minus again integration. Again with the integration we will get sine a minus b, and again when we will separate out this and this gets cancelled and we get tan x minus a dx, and you know integration of tan x, right children? So this is how you will complete exercise 7.3. And in the next video, I will talk about type 4 integration, that is integration of some particular functions. And there's a very, very interesting method which we will use. So keep waiting for my next video. Thank you.